So I'll read from my crib sheet here. So good evening, everybody, and I'm Jackie Jones from Herefordshire Green Network. Welcome to this latest Building Sense event. Fortunately, it's been chilly, grey and miserable all day, which has kept our minds on heating. And of course, there's plenty going on in the world at the moment to focus our minds on exactly why using less heating fuel yet staying comfortable is really relevant in everybody's lives and in the buildings that we use. Anyway, this evening we're going to be hearing from Greg, sorry, just letting someone in, from Greg Collier-Jones, who works with Severn Wye Energy Agency, and he's a trained retrofit coordinator. He might say a little bit more about that, but it's a national qualification to ensure high quality retrofit work is carried out. So it's in compliance with a fairly new standard that's being rolled out. And you might know about Severn Wye Energy Agency. Amongst the many other things they do, they work on the Keep Herefordshire Warm service, which offers advice and support. I'm sure Greg will say a bit more to that. Now, before I introduce Greg, though, I'd just like a couple of my colleagues here to say hello. So one of them is Gordon Coppock, who's going to be fielding questions and chairing our next event. So Gordon, give us a
hello
wave. Yeah, that's Gordon. And I'm going to surprise somebody else, Gemma Monk-Hartley, just to say hello. Gemma's going to be joining the Building Sense Initiative.
Yes, looking forward to meeting you all more.
Yeah, she's going to be joining us to help us be a whole lot more professional and roll out a whole lot more than we do at the moment. And we've got some quite exciting new plans that we'll be able to tell you about later. And Gemma's going to be really involved in rolling those out. So anyway, how many of our participants do we have now, Gordon? Can you see?
24.
Okay, then that's fine. Well, look, I tell you what, Greg, we will let you start in a minute, but I'm going to try to do a bit. No, I won't. I'll just do a bit more spiel, and then we'll roll on to a poll to get some inputs from you. We're starting now at 5:30. We should be finished by 7 at the very, very latest. Greg's going to be speaking for around half an hour, and then we'll do a Q&A session. So we know everyone's busy. We won't drag it out. If we're all done before 7, that's fine and dandy, but otherwise that's when we'll go to. Right, I'm going to attempt a poll now. Sometimes I can make this work, sometimes I can't. So let's see. The idea is we just get to find out, because we can't get you all to speak, just get a bit more dialogue. Ah, there you are. My polling is the same thing has happened again. I think this is because our recording person is also logged in. So yeah, that's it.
Have you tried to launch it, Jackie, and it doesn't launch?
Yeah, this is what happened before. I think it's because we're being logged in from elsewhere. Okay, let me try. Sorry, folks.
I've just tried to launch it as well.
I can't get there at all.
Pardon?
Something has come up.
Have you got the poll on the screen, Gemma?
Yeah, it says your home or maybe workplace and
That's it. I've launched it, Jackie, all right?
Oh, that's terrific. Oh, well, that's wonderful. I can't see that, but that's marvellous. So I'll, when we get to the results bit, then, Gordon, I'll ask you to take a photo of that then.
Yeah.
So Gordon, or indeed Gemma, since you're there, I can see stuff that I can't. Would you just read out the headings of the questions and ask people to make their choices, please?
Yeah, so the first one is your home or other building. We've got a single choice answer Is it usually a comfortable temperature in all or most rooms? Does it get uncomfortably chilly in winter, even with the heating on and stoves lit, or is it uncomfortably chilly? Heating is too expensive to run. Then question 2, we've got your plans for an energy makeover, retrofit. Are you seriously interested in making significant upgrades in the next couple of years? Can you not imagine doing anything other than a cheap and simple fix, or you just haven't thought about it much but want to find out a bit more?
Okay.
Yeah.
So about 13 of you have responded so far. If anybody's got any problems in doing so, we can help. 18 of you have responded. That's good. 19, nearly there. 20 have responded. I can't respond, obviously, because I'm doing it. But there you go.
Me neither.
Okay, we've got 21 of 95, so that's good. So the vast majority, before I end it, I'll actually say what it says. So about 68% are saying it's usually a comfortable temperature in all or most rooms. That's very good. 27% gets uncomfortably chilly in winter, even with the heating on stoves lit. 5% it's uncomfortably chilly, heating is too expensive. And on the second question, I'm seriously interested in making significant upgrades. It's 82%. I can't imagine doing anything other than cheap and simple fixes, 9%. I hadn't thought about it much, but want to find out more. That's 9%.
That's great. And before you end it, Gordon, could somebody please...
I've done a picture, yeah. I've done a
Fantastic. Picture. Okay. So apologies for my bad driving. Cool. Thank you very much, Gemma. Thank you, Gordon. And now let me introduce Greg. So off you go. Thank you.
Hello. Thank you very much, Jackie. And thank you all for coming. And thank you for having me along. I was here, it feels like about a year ago, actually, when we first this was sort of first mooted as a thing. So I will get my screen share going and my thingy up. Okay, so welcome to this presentation. We called it "Where's the Heat Going? Where's the Money Going?" And we're going to talk for, as we say, about half an hour. I've got about 22 slides, some of them heading. So about heat loss in buildings. My focus is primarily domestic setting, but a lot of this rings true if we're thinking about commercial setting as well. So it's all much of a muchness is this bit. I've got to warn you, there's some maths involved, but please don't press me too hard on the maths. This is more fundamentals of how we calculate U values, and if I'm doing it in the real world and in anger, I use a thing that does all the hard stuff for me. So please don't worry too much when the equations come up. They just give a little bit of illustration. So firstly, I just want to introduce Severn Wye, who we are and what we do. So we started about 22 years ago now, working in the Forest of Dean, focused on fuel poverty, and we quickly expanded. We mostly been associated with Gloucestershire for many years, and about 5 years ago we came in and took over the Keep Herefordshire Warm scheme. And we're working across both areas as well as the whole of Wales. So lots of information on this slide, and I'm trying to get a cut down one made. But we do things like fuel poverty support. We do training and education, so things like this. We work with installer networks. We have our own sort of installer search site called Linked Energy, where we vet all the installers and make sure they're fulfilling and up to standards, up to certain standards. We help individual households with decarbonisation, which I think we'll talk a bit about later on. We have a big community and business side. Our target 2030 scheme in Gloucestershire. We've got Beep, I think it is, in Herefordshire. doing work on that sort of decarbonisation of small to medium-sized enterprises. We work with social housing providers as their retrofit coordinator, working on big multi-property schemes, as well as public sector buildings. And in Wales, we're working as well, really interestingly, on energy technology, so carbon capture technologies, such as, what's it called? Anyway, we cook bio waste to create biochar. There we go. That's the one. Creating biochar from cuttings, from verges, down to sewage effluent, and finding new and innovative uses for that. We operate, as I've said, Keep Herefordshire Warm. So that's funded by Herefordshire Council. We provide free energy advice for all Herefordshire residents, 0800 677 1432, or via our website. We have quite an active blog talking about current affairs and current energy stuff, so that's often well worth a read. We focus primarily on fuel poor households, so helping low-income residents access grants, make fabric improvements and system improvements to their home. We also have an advocacy scheme that will support more directly with bills and billing issues. As I've said previously, we run CPD like this, and well, this is more bespoke, but CPD. So we're dealing with frontline organisations, we help them understand and approach fuel poverty and identify it a bit better. We also host the Herefordshire Affordable Warmth Network, which meets twice a year to discuss the issues and what's going on in Herefordshire. So what we're going to cover, the rationale first. We're going to talk about why heat loss is so important, why we're doing a whole 30 minutes on it. I could go on for much longer, I promise you, but you'd probably get bored. So we're going to look at typical heat loss profiles. We're then going to spend most of this looking at the mechanisms for heat loss, so through the building fabric. We're going to discuss U values. It's a term banded around a lot, and we're going to build up and see how those actually come into being, what they actually tell us. And we're going to talk about ventilation as well, and how ventilation, and how we lose heat through ventilation. We're going to talk right at the end a bit about reducing heat loss, but I'm not going to talk too long on that because there's another talk next week. I believe it's on the 9th, but I'll leave that up to Jackie to talk a bit more about later. And that's on small measures you can do to help you reduce your heat loss. So why do we need to address heat loss? So in 2019, a new standard came out, and that's called PAS 2035. That's something Jackie alluded to earlier, is it's a new way and the best practice way of approaching retrofit in our homes. Other standards like Passive House do the same sort of thing, and all of these schemes and all of the best practices telling us the first thing we need to do is address heat loss in our properties. It's not about the solar panels, it's not about the air source heat pumps, it's about making sure we're using as little as possible. The cheapest energy is the energy you do not use. So it's those kilowatt hours we manage to stop ourselves using that are going to save us the most. And if we get heat loss wrong, we can create significant problems in a household, and that could also be overheating as well as underheating. So PAS 2035 and the sort of best practice for doing a retrofit scheme starts with assessment and planning. We then need to address defects, so things that are wrong with the property, like leaks, like cold spots. So it's fixing those first, and then it's the fabric, and that's where we start to address heat loss, followed by building services, so heating systems, and then it's really the renewables. There are reasons you'd go a different direction, but if in the ideal circumstance, the first thing we meet is the fabric of the building. Heat loss mechanisms. How and why do buildings lose heat? Now, I hate this diagram. Before we go, I first saw it back in 2012, so I'm pretty sure houses and what we've done has moved on since then. I'm pretty sure we could do with a new diagram, and I even then I can't actually ground truth. I can't find the original source for it. I'm pretty sure it's someone selling wall insulation, but there we go. So it's based on a typical semi, assuming 100mm of loft insulation, which was the building regs back in the 90s. Unfilled cavity walls with double glazing installed before 2002. So it's not every property, and we'll come on to that. But typically, and the other assumptions I've made here are that we're assuming eventually all heat escapes from properties, and that space heating is what we're currently estimating is 69% of an average bill. And average bills, based on the latest hike, we're looking at about £2,000 for a household. So that's my assumptions. So through the roof, going from 12 o'clock through the roof, we're looking at losing about 25% of our heat. That's probably changed a lot with decent home standard. So that's possibly one of the most out of date figures. And we're looking at £345 a year, given that typical bill, escaping through the roof. Next around is windows, and we're talking about actual loss through windows, so through the actual fabric of windows, and that's about 10%. Single glazing, it will be worse, but not a lot. Windows are surprisingly a small amount of heat loss in most properties. Drafts coming through the gaps in windows, however, may be a lot more. So we're looking at 15% and £207 just being blown away by drafts and breezes. And there's a couple of ways that can happen through ventilation. The floor is one we're really not addressed yet, or we've not addressed in the last few years. So this one I can say is probably still very similar, or a bigger proportion now. That's the floors, and we're looking again at another £207 eventually escaping out the floors. The walls, back when this standard map came out, this standard picture, we were looking at 35%, so £483. But over the last 10, 15 years, we have addressed and we've treated a lot of the cavities that we can in this country. So we're probably seeing a lot more. Also, please forgive my paint drawing. I was trying very hard to not pick up on any copyrighted images. So this image has been reproduced many times, but I had to sketch it out again. We call it outsider art, I think. However, all buildings are different, and these mechanisms and these proportions will vary from home to home. I'm sorry about the fuzziness of this one. So this is from the Retrofit Academy, links up there, and it's based originally on some work done by Parity Projects in the London Borough of Sutton, both really good organisations, and it's giving pictures of different properties and where the heat loss is. So these are all similarly built properties, but with small changes. So just picking on a few, in this one we can see, so the one my mouse is circling, hopefully you can see that. We can see 39% going out through the walls. But in this one, we can see it's only 17%, and they're losing a lot more through heating efficiency. So that's perhaps they've had the walls treated, and that's pushed up some of the other factors in the household. Very similar sized bubble. So we've got the same sort of level of heat loss, but we've got very different things contributing. So that's the really important thing here, is every home is different. So when we look at this picture, it's probably not true for your home. It's probably not true for any home anywhere. So the really important thing is, if we're addressing heat loss, is to actually sort of talk to someone, get a survey done, get to understand your home specifically, because that's the really big thing. Is your home is absolutely unique, and what works for one person might be completely wrong in your home. And without seeing your home as well, it's very difficult for someone, an energy professional like myself, or some of the other people that are going to talk in this series or talking in this series, to give you any advice. So heat loss. We lose heat through building elements. We lose it by conduction and then ultimately radiation. So through the wall, the heat will go out of the room. It will radiate throughout the room. It comes into the wall and it's absorbed by the wall. Heat, like everything, will flow. So heat flows from a warm place to a cold place, and it's trying to get to this equilibrium. It will be conducted through the wall and ultimately be radiated out the other side. Heat loss can then also be, and we've seen that big factor is through ventilation. There's two forms of ventilation we're talking about, and that's stack ventilation and by pressure ventilation, or positive pressure ventilation. And then there are internal heat gains. So when we're thinking about heat loss, if we wrap all our buildings up too tight, we don't think about heat gains, we can end up with the opposite problem in the summer. So we've got heat gains through people and pets, through appliances and lights, and the big one and the biggie is uninsulated hot water systems. And then I have missed off here external heat gain through insolation. So the sun striking windows and striking walls, and actually heating our properties up that way. So pinging on to fabric heat loss, and this is where we're going to get a bit mathsy. So U values is something we've all probably heard. Hopefully we've all heard the word U value bandied about, and a U value is essentially the sort of what we hear about as sort of building elements lose. So where that starts is thermal conductivity. Now this is tested in a laboratory. So this is understood by testing the materials we're using in a building, and in a new build we test and we know what every single material is. In retrofit, so where we're dealing with older properties, we don't necessarily know exactly what the bricks in the wall or what these values are for the bricks in the wall, so we do have to make some assumptions, but some typical values are here and sorted in sort of order. So materials like steel lose heat incredibly quickly, and aluminium's even worse. So aluminium windows and doors, really bad. But we're looking at potentially 16 to 80 watts per meter. Now, when we come right down to things like brick, we've got 0.62 to 0.84, which is a typical building material. Glass is 1 and 1.05. But then coming down to the actual insulation materials at the bottom, so wood fibre board is 0.11, so that's a natural, what we call a natural insulation, so it's not got any plastics in its production. So 0.11, and then some of the more manufactured materials like mineral wool, which is essentially that spun fibre you see in your loft or put into cavity walls, is 0.04, and then phenolic foam, which is a closed cell foam, have a really high value of 0.02. So to get the same, essentially from this we can see, to get the same effect as so if we take 100 ml of phenolic foam, we'd actually need 200 ml of mineral wool to get the same level of thermal, or the same resistance. So moving on, so from the thermal conductivity we can calculate the thermal resistance. Equation's quite a quick one. It's the thickness of the material over the thermal conductivity, which we've got from the previous table. So it's the ability of a given thickness of material to resist heat transfer over its surface area. So the higher, so here the lower the value, the better. Here, the higher the value, the better. So this is the one you'll often see quoted by materials manufacturers, because it's the one that's easier to sort of get your head around. Big is better rather than small is better. Building up a cavity wall on the right here, we've got, and I've taken off things like plasterwork because that adds an extra layer of complication, but bricks with a lambda of yeah, my formulas have disappeared. Excuse me a second. Font color. There we go. I changed the colors because someone said that might be a bit challenging to read. This might still be a bit challenging to read, but at least it's back now. Right. From that, so we've got this thickness of 0.1 and this lambda value of this, yeah, is that lambda? I'm never sure. Anyway, the thermal resistance, the thermal conductivity of 0.7. So that gives us 0.14 Kelvin per watt. Kelvins per watt. Not to worry too much. The mineral wool, we've got a much thinner amount of mineral wool here. So actually just jumping down to a solid brick wall. So a solid brick wall is double the thickness, and we're looking at a lambda value, that R value of 0.29. So by doubling the thickness, we actually get double the sort of resistance. That's what that's for, and we'll come back to that in a second. Mineral wool, so this middle layer, half the thickness, is actually far more resistant than the bricks or the breeze blocks on the other side. And then this block work, again, 0.14 with the same sort of thickness as the brick, we're getting the 0.07. So that's worse. That's a dense brick block work. Some of the lighter block works do perform a bit better. We then bring in surface resistance. These are always constants. So that's the ability, so the heat's ability, it's just the resistance of a surface for the heat to come in. So from conduction, from radiation to be conducted into the wall and to be conducted out the other side. And then we've got sort of upwards and downwards as well for roofs. Not to worry too much, it just comes into the overall calculation here. So solid brick wall on the left, so U value, finally we get to this U value that we hear about, which U values, again, like golf scores, the smaller the better. So we calculate that by taking each of the layers of, we take the surface and the external resistance, and then add each of these layers of resistance together, and then divide 1 by that value, by that total. In the example of a solid brick wall, just taking, we've got that 0.29 resistance value. So we've got the R1, 0.29, and we've got the internal heat transfer, so the resistance to heat internally, and the external heat transfer. So what we end up with is 1 over 0.13, which is the internal, 0.29, which is coming from that solid brick wall, 0.04, which gives us 0.22 watts per meter squared Kelvin. So the area of the wall we can then take and actually calculate the heat loss from. Then in the example of a cavity wall on the right here, we got that brick is the same thermal resistance, but it's much, well, we've got the same thermal conductivity, but we've only got a thinner layer. We've then got this mineral wool, which is doing most of the work. Then we've got this block work on the inside. So again, so from there, with a filled cavity, with that mineral wool, we're getting 0.61, which is more than half that of the other wall. If we were to take this out, which I haven't done, with a solid brick wall, with a cavity, unfilled cavity, we'd actually see it's worse than a solid wall, because it's because you've got that block work on the inside that just doesn't perform as well. So that's U values. U values are the thing we'll probably hear about a lot when we come. If you're ever buying insulation or speccing insulation, U value will be what gets talked about. But these other things, these other areas are what go into building those U values and how we get to them. The next element of heat loss is thermal bridges. So I've got my wall, but no wall is necessarily solid in a house. So we might have pipes. Well, we will have pipes and things coming in from the outside. We will have places where the floor meets the wall, and we will potentially get places where we're joining things to the outside, which all increase heat loss. So we call these thermal bridges. So they're places where there's a discontinuity in the wall with a lower U value than the surrounding material, which means we get a much faster heat transfer through that. So a point bridge might be something like this pipe in the bottom left corner coming in. A linear bridge is potentially where we've got a concrete floor meeting a wall, and that gives us, or a concrete, the big one, the famous one is balconies. And back in the late 60s, early 70s, we put a lot of concrete balconies on buildings which just suck heat out through the floor, so they were thermally continuous, so you get to see a lot of damp around there, and that's called a linear bridge. The other element might be if you've got a concrete lintel above a door or a window, which has a much higher rate of heat loss than the surrounding brickwork, especially once we insulate. So if we've got an uninsulated cavity and a concrete lintel, we might be fine. But if we then add insulation to the cavity, what we're going to do is make that thermal bridge more extreme. So that concrete lintel, where it wasn't before a cold surface in the building, it suddenly becomes a cold surface. And now cold surfaces lead to a risk of condensation of moisture, which is the big thing we want to avoid in retrofit. And it's one of the big parts of retrofit risk management, is avoiding that sort of moisture risk. So we've got to be careful in our retrofitting that we design out these bridges, or we do something to mitigate against them. The final one is repeating bridges. The most common place for this to occur is actually where we are installing insulation. So if we are dealing with a solid wall property where we can't fill the cavity and we want to add insulation either to the inside or the outside, we might create what's called a repeating bridge with the material we use to join that insulation. So it might be a metal frame, it might even be a wooden frame, and wood timbers. So in loft insulation, we started out with 100 mil loft insulation, and that didn't cover the joists in our ceiling, and those joists could risk becoming a thermal bridge. So we've then gone up to 200 mil where we've covered them, and then we've covered them again. And I think actually the newest building regs, we're going up potentially to recommending 400 mil loft insulation. We'll talk a bit about that later as well. Hopefully, if I've got time. Heat loss through ventilation. So moving on from that, we've then got heat loss through ventilation. So that was all of 85% of our heat loss is actually coming through the materials, and only 15% is lost through this sort of ventilation, potentially. It depends again on your house. If you've got really drafty windows, this is going to be a bigger factor. Windows and doors, this is going to be a bigger factor, but heat loss through ventilation. So there are two main drivers of heat loss through ventilation. Again, excuse my really poor drawing. I do want to get my comms guy to do me some pictures that will work better, but hopefully this illustrates. So the first one we're going to talk about is called the stack effect. So heat transfers by sort of three things that we learn in science. So you've got conduction and radiation, which we've already talked about, and that's the loss through the materials. And then we've got convection, which is the nature of heat to rise. So as air is heated, it becomes warm and it becomes less dense, which makes it lighter than the surrounding cold air, which means it raises to the top of a building. If we're dealing with radiators, so most radiators on walls are actually convectors, and they're convecting heat around it. It's the effective way of moving heat around in a space. But that hot air will move up to the top of the building, and it has to fill the building down slowly. But that will also create a pressure at the top of the building. So it will then look for spaces and gaps that it can escape out the top of the building. So that might be gaps in the eaves, gaps in the insulation, gaps around a loft hatch. And it's going to pass out of that. And that's then going to lead to a reduction in pressure at the lower side of the building, which will suck cold air in from the outside. That's what these blue arrows here are, is the air being sucked in from the outside. The next one is positive pressure. So we've all experienced it recently. It's been very windy in this country. So the wind's going to hit our building from one side. It's very rare that it will hit it from all sides at once. If it's doing that, you're probably in a lot of trouble. So the wind is hitting our building from one side, and that's going to find any gaps in our building envelope. It's going to look for the gaps in our insulation. It's going to look for the gaps in our windows, and it might even force the gaps in our windows. So even if we have got them insulated quite well, it might actually be able to sort of force its way through those gaps. And that's going to push cold air into one side of our building, and that's then going to force the warm air out the other side. As we get pressure in building in one side of the building, the warm air is going to be lost out the other side. This is, in part, it's useful in some buildings, but it's generally better to control ventilation and understand where the heat is going, rather than let it happen in a natural sort of way. Wrong screen. Okay, so moving on, and I seem to be doing quite well for time, so I think. So moving on to sort of reducing heat losses. So the first thing we need to, or as I've said, this talk is really about addressing building fabric and the importance of doing it first before we then go and do other things. If we just quickly on that, if we don't do it first and we put a heating system in and then we insulate the building, that heating system is going to be oversized. So we might see losses from we might then see that the heating system is forced to cycle, and it runs less efficiently when it's running at less than 100% or less than its optimum design capacity. And then we end up with actually higher costs from our system. So the ideal is always to reduce the heat loss to the minimum before we then address the heating. There will be situations that in retrofit where the heating is broken, and we've got to replace it for the inhabitants, for the occupants. But in most cases, we want to hit hit the heat loss first. So insulation, and I am sort of doing this quite quickly because there's plenty out there. And each building as well is different, but these are general ideas of sort of things to do. Loft insulation, you can go up to 400 mil plus. It's £17 per roll. You're looking at 300 to 1,000 to do it yourself, maybe 2,000 to have someone in to do it. Don't do something you're not safe doing, but that's one. But we are going to talk about some risks as well in a minute. Cavity wall insulation, if not already done, £2,000 to £3,000. Older fills might have failed. These can be extracted and refilled. They'll also be of a lower U value. So the U values of the cavity wall insulation installed back in the late 70s, early 80s was about 0.7. The modern stuff is going down as low as 0.3. So it's better than it's more than half the heat loss through that wall. Additional, so if you're in a solid walled property, there's a lot less to that can be done. Solid wall insulation is incredibly expensive, and it's a very high risk measure. So insulating solid walls, it's really best to consult with sort of professionals there and get it properly designed. The ideal and the optimum is always external, but in many cases a solid wall property is probably listed or in a protected area, and therefore you can't necessarily get that external wall insulation on, and you're looking at sort of a £20,000 price tag there too. Internal wall insulation is a lot easier, but there are risks associated with condensation and damp forming between the panes, and best practice is still not to go down too low on that. With cavity walls, if we've got issues, so we've got our cavities, we've got them filled, there's nothing to stop you if you've got a problem area where you're noticing damp and condensation forming. There's nothing to stop you coming back and putting an insulated plasterboard on there to further enhance your U values. You can do that, and that will give you a better energy performance. Additional wall insulation in cold areas, so yeah, specified plasterboard. Again, I always say with these things, it's worth doing it. The best time to do it is when you're doing the work anyway. So if you're going to be replastering, consider specifying an insulated plasterboard rather than just plastering straight onto the wall. You're going to lose a small amount of space, but with energy costs going the way they are, you might find that the savings pay themselves back, and you're looking at getting 100 years for 50 years. I don't know how long plaster lasts, but anyway, you're looking at a long time that measure is going to be in place. Flat roofs are the really big one that really doesn't happen. Flat roofs are a brilliant thing that someone came up with. And unlike a normal pitched roof, they have about a 25-year lifespan, or the older ones do. The old felt ones sort of tend to start leaking after about 25 years. Now they start leaking, and no one was expecting, and no one wants their roof to start leaking. And that's the point. They get someone in to look at their roof and replace it. Now, a flat roof, you're probably looking at £500 to £1,000 to replace. If you start specifying insulation in there as well, it pushes the price up, and most people in that situation are going, oh, I can't really afford to replace the roof as it is, and go for the quote that doesn't involve insulation. But it's a really important thing to sort of, when you're doing something, it's much better to do it when you're doing that job than it is to have to come back and try and do it later, try and do it internally or something like that. Underfloor insulation. Now, solid floors. So most properties built, or a lot of modern properties, or more modern properties, have solid screed floors. These are really difficult to do, and most people are not going to choose to do them as part of their retrofit, because it means having a guy dig up your whole floor and starting again. Which is a case of moving out of your house for a week or two whilst they do it. Underfloor insulation of suspended floors can make a huge difference. Historically, it has required digging up or taking up all the floorboards and laying insulation in nets and things. Very important when you're doing things like that to be very careful of airflow under the floor. But there are companies out there who are coming up with really techie solutions. So an example, and maybe not the only product on the market anymore, but they were the first, is Qbot, who had this little robot that they put in under the floor, and it sprays foam insulation up from the underside of the floor. Of course, it's always worth checking out local building regs and things with that one. But it has, by all accounts, it is a good system in my opinion. So the risks of insulation, and this is the real sort of big one, is a lot of historic retrofit has done insulation, gone in, done insulation, messed it up, and we have a lot of cases in the news. We see a lot of cases in the news of failed cavity wall insulation. of failed solid wall insulation, and things like this that have made houses unlivable, and cost more than the actual initial install did to then replace. The first thing to talk about is the law of diminishing returns. So going to loft insulation, the first 100 mil does most of the work. So let's say that first 100 mil does 50% of the work of insulating your roof. You then put another 100 mil on top of that. That's only going to do 25% of the work, because the heat getting to that layer is much less because of that U value of the first layer of insulation. We then add another 100 millimeters. That's going to half that again, and we're going to keep getting a smaller amount and a smaller amount. As energy costs go up, so this is one of the reasons why we've specced up and we've kept specking up loft insulation. We've seen loft insulation go from 100 mil to 200 to 270 to 400 plus now. Is that as the cost of energy goes up, the value of that extra little percent of energy saved is important, becomes more. So we will see that gradual increase in the value of insulation, and eventually we'll get to the point where actually, yeah, we do come back, and a lot of the modelling for our 2050 targets sees us coming back to the insulated cavities and actually doing external wall insulation on most properties in the UK. Thermal bridging, as we discussed earlier, thermal bridges. Increasing insulation will increase the rate of heat loss through a thermal bridge. So careful design is important to prevent this. Another issue with thermal bridging is where we're insulating semi-detached or terraced properties. We're insulating one and maybe the neighbour's not being done for whatever reason, the neighbour's not doing it, is you actually can risk a thermal bridge coming in through the party walls. So best practice now with internal or external insulation is also to insulate about, I think it's 2 or 3 meters in through the party wall as well, to prevent that diversion from the outside. Damp and condensation are a huge risk, as I've said. Not only so, insulation can improve the air tightness of properties and lead to higher humidity, cold surfaces as well. If we're not doing all-round insulation, we risk having one surface becoming cold. And I always do my house as an example here. I've got a 70s place, 60s place we've got a little bit of eave, a little bit of pitched roof in our top floor. So they've done the loft insulation, they've done the walls, but what that pitched bit has become the cold surface. So I've had to then strip all the plasterboard back and go in and put additional sort of phenolic foam in behind that to stop it becoming a damp problem in my house. Another one with this damp and condensation is so on solid walls, if we insulate internally, we get a risk that we get something called vapor diffusion. So rain falls on a wall, the sun hits the wall and heats the wall. The water that's in that wall will evaporate. Some of it will evaporate out of the wall, but some of it will become vapor and start being driven further and further into the wall. As we get more and more vapor, it drives the moisture further and further into the wall. And on an old solid wall property, the idea is then the heat inside that nice hot fire that we used to have in these properties heats the wall up and drives that vapor back out of the wall. Now, if we put too much internal wall insulation in, if we reduce the U value of that wall inside down too far, that doesn't happen. We're going to get to a point where the moisture, the vapor, diffuses all the way through the wall and hits the back of the insulation and can cause what we call interstitial dampness. So it's about controlling those risks and understanding those risks before we just start slapping insulation everywhere. Finally, there's thermal bypass. If we don't do the job well enough, we don't insulate well enough, internal or external air will pass behind the insulation, making it nigh on useless. So we've got to make sure that insulation that we are retrofitting is nice and tightly fitted and sealed all round. Otherwise, we get this thermal bypass that just means we're doing nothing. Draft proofing is the next step. So that ventilation again is a big thing to tackle. Check seals around windows and doors. Seals on UPVC frames can be replaced. So even if your windows are older, if you're feeling drafts around them, it's not necessarily a sign you need to replace the UPVC units right away. You could get someone in to look at the UPVC, or you could do it yourself. You can get packs off the internet. I've got some somewhere, but they're not visible to me immediately, of samples of different seal types, and you can run around, find the right one for you. It's just a case of ripping the old one out, stripping the old one out, and push fitting the new one back in, and that's going to stop drafts coming through your UPVC windows. We do see some where they've settled and the hinges have gone. Again, that's probably fixable by someone. Wooden frames can have additional draft proofing applied to the frames. So if you're stuck with timber frames, there are things you can do that can be easily removed. So if you're stuck with in a conservation zone, there are brushes you can get for sash windows to reduce drafts. And door frames, look up stuff like Storm Guard, that can be fitted around the frame just to reduce the draft, coming in through that. A lot of places these days as well have unwanted chimneys, unused chimneys. A lot of us don't use open fires anymore. So things like chimney sheet or chimney balloons can be put up there to prevent the draft and reduce that stack effect escaping up the chimney. You also get an effect on the top of the chimney where the wind blowing across the top of the chimney, like the air across the top of a bottle, causes air to be sucked out of the chimney, sucking the warm air out of your living space. So get that sealed up, get it sealed up soon. But again, be careful. If you're already having issues with damp and mold, you should resolve these before treating the drafts. And that might be a case of putting extractor fans in your wet rooms, because it's much better to have, again, as I say, controlled ventilation rather than uncontrolled and escaping from your living room. So taking the example where I said the chimney is sucking the air in, sucking the air out of your living room, you've then got a damp room next door. That chimney is actually going to suck moist air from your bathroom or your kitchen into your living room, and which could then condense on your living room or bedroom walls, leading to a damp problem in your living spaces. So it's about being careful. So draft proofing. So if you are draft proofing, if you are insulating, but if you've already got a damp problem, do be careful and do look out for getting that looked at. So that's me. So I've been Greg Collier-Jones. I am around for questions, and so I will hand over back to Jackie and thank you. And I'll answer any questions now, I guess.
Brilliant. Thank you so much, Greg. That's terrific. So not only heat loss, but heat loss and some of the remedies for it. Let's give you a brief rest while we come back and do our second poll, if that's all right. So I know some people are probably kind of having their supper or listening while walking the dog, but if you can get back to your screen, please do come and take part in this poll. Greg, you got into a lot of detail about the fact that different homes are, every home is individual, every building is individual. The principles are the same, but the solutions for different buildings are going to be specific. And so I would like Gordon and Gemma to repeat their trick on the polling, as I'm unable to do it from here for some reason. We've now got some questions about whether what you see as the value of actually having a tailored report done on your home. This will all become clear later on when we tell you more about our building sense plans. So if you could launch it, Gordon, and Gemma take us through. The first question, it would be great if everyone could answer. And then the second one is only for people who don't say no to the first.
Okay, just launched. Hopefully you can all see that. 2 questions.
See them. So the first question, do you think a tailored report for your home or building would be useful? Definitely, no, or maybe. And then if you answered no, you don't have to answer this one, but if you didn't, how much do you think you would pay for a detailed report? Would it have to be free? No more than £100, up to 200, or up to 500?
Okay, that's good. That's nearly everybody answered. I'll just take a photograph of it whilst I remember.
Thanks, Gordon. And everyone can see it apart from me. So go on, read out the answers for me, please.
I'll just take a photo and then I'll end it and then I'll share it. Okay.
Okie dokie.
Okay. Thanks for all sharing that. Can you see the results? Yep.
They're on screen.
Can you see them, Jackie?
No, I can't see anything apart from
All right.
lots of
Well,
lovely faces.
The first 78% was definitely on the first question. Do you think a tailored report would be useful? Well, after Greg's talk, I think the answer must be yes. And for the second one that followed on, up to 200 quid was about the most popular figure. So that's useful. Thanks for that.
Yeah.
All right, then I'll stop sharing that.
Terrific. Thank you ever so much for that. It's really interesting to get a sense of this. So some questions for Greg. I know that Gordon's been fielding a few from the chat. There've not been many yet. Gordon, you might have a couple of questions prepared that
yeah, I'll do
noting down.
I'll do the ones from the chat first, and then we can continue on with some others if need be. But if whilst we're discussing these questions, you think of others, please put them in the chat, and we'll try and address them. Okay. Greg, we can see from Nina there, we had Nina Shields. Where do you start with checking old filling to cavity walls? And I must admit, personally, I've had this problem with my house, so I'll be interested.
So most of not all installers, not all cavity installers will come out and survey your cavity for free. Now, I'm not sure how many of them will tell you that your cavity walls failed no matter what. It's in their interest to, and just like it's in my interest to say, get a survey done. Not making any specific recommendations. We've got a website linked to Energy, but there's a local company called Evolve Energy Solutions who do this sort of work. So generally, if you get in touch with them, they'll come out and do a free boroscope of your cavity and be able to tell you what's going on in there, whether it's worth refilling. You'll possibly know that there can be slumping, which is something that can happen. So you'll have sort of possibly like damp waves along the top of your wall and things like that. But yeah, it's then possibly Thermobede are the other company working in the area who I know of. But do just check out linktooenergy.com or Trustmark is the government scheme for those sort of companies.
Okay, thanks. I mean, just to back you up there, in my case, I had one of the companies who was trying to put in a government funded in cavity wall insulation, and they're the ones, because they had a self-interest to do it, because they only got paid if they do it, they told me they couldn't do it. So I kind of believed that at that time. And then subsequently in recent years, I've had Evolve out to do just as you said, and they've been pretty good, and they've given me a price for taking the house apart and taking all the insulation out and so on. So yeah, thanks. Okay.
Yeah, I've seen them do it recently. They've got a big, it's a big vacuum cleaner, like the things that go in a bouncy castle. They cut a load of holes in the wall, stick this vacuum in, and it sucks it all out into a big bag.
Yeah.
It's a shame we're going back and doing it because there's so much plastic and carbon invested in that, but where it's failed, it's better to get it replaced.
Well, mine was a 70s type, and it's like a spider's web, and there's nothing to it. It's really hard to find it anywhere, but it's just visible in the bottom of the cavities, and that made the new installer refuse to install it because it would infringe their warranty. So it's only tiny amounts left, and when I've done cut-throughs and changes, you can't see any evidence of it. But that was a 1970s or 80s fill that's useless. Okay, another question from Nick Sherwood, I guess. Hi, Nick. Older fills can be extracted. Is the question, if he has 25mm rock wool in a 50mm cavity installed in the mid-80s, could these have failed anyway, or could you extract it? That's a bit different because that's not cavity wall insulation, but I'm sure we could comment on that, Greg.
Yeah, so that's what we call a partial fill. So it's what they did in the 70s and 80s, was they used to put solid board on the internal leaf and leave the gap. We'd rate that as a hard to treat cavity. Now there is the possibility that if none of the leaves, none of the boards have fallen down inside the cavity, they can just come in and retrofill. Alternatively, these can be extracted in the same way. I'm working on a project elsewhere where they are extracting the old board. Unlike a rock, unlike a mineral wool one, they can't just stick a vacuum cleaner in. They've got to get a tool in that just spins around and sort of breaks it all up, and then they can vacuum it out. Again, it would be someone like one of these, Thermobede or Evolve, could survey the cavity and advise you. They use a boroscope and a camera to have a look around, and then can tell you what's going on, whether it's failed, and whether they can. And some of the newer fills, so where in the past we wouldn't have been able to fill a partial cavity fill, some of the newer technologies can go into a 25mm gap.
Do you think that, from what you said, for example, with regard to the roof insulation, that the first 100mm is the most productive or the most sensible to do in terms of the cost benefit? Isn't that also true for cavity wall insulation? So if this is okay and it's not causing heat bridges or anything, heat losses, would it be best to leave it as it is?
You're going to be spending a bit to do a partial fill, and it's going to cost you a lot more to extract and refill. If it's all fixed in place and working, and they can't, because I'm not an installer, so I don't know necessarily the art of the possible there. If it's fixed in place and they can't do a partial, so they can't top it up, the extract is going to take a long time to pay back, basically.
Okay, next follow-up to that is would only pay for a survey if it was detailed in the sense of specifying priorities, materials and techniques necessary to make improvements. I see. That was feedback on the survey. Sorry, Nick. Yeah. Okay. Next one down is how much difference, this is from John Cook. Hi, John. Differences to heavy drapes curtains make over windows and doors. And that's an interesting one because I've actually seen a comparison between double glazing and heavy drapes, heavy insulated curtains recently, and they're similar.
Yeah, huge difference. So where you've got drafts, they are really useful. Closing the curtain has two positives as well. So the other end of it is the summer overheating aspect. and being able to close that curtain and close the heat out is also an important factor. Yeah, I'd go with, if you can, double glaze and curtains. But no, curtains are heavy curtains and well thermally lined and thermally performing curtains are very valuable part of the toolkit.
Okay, good. Annie Wood says, we have a lot of condensation in the rooms at the front of the house with UPVC bay windows. It seems a lot of factors need considering. Any thoughts where we should start?
So yeah, UPVC bay windows. A lot of these bay windows are especially if the UPVC is sort of older make, it won't be so well insulated. So the old UPVC frames were just hollow plastic. The modern ones are quite high performing with internal plastic, with internal insulation in the actual frames. So it would be a question of whether there's the UPVC is going to be a cold surface in the room. So if it's on the window panes, if it's on the glass, you could look at getting the glass, so replacing the actual double glazing unit rather than the whole window. This is a lot cheaper than getting the whole frame replaced, because if it's condensing on the window and running down the window, you could go for just an A-rated glazing module into the old unit. Alternatively, it's then sort of looking at replacing those windows, but also making sure you have adequate extract in the bathroom and kitchen. So they're sort of recommending sort of continuous extract ventilation. So modern houses are tending to be built with a fan that's always running in the bathroom. So taking that stale air and making sure it's going out that way, and then bringing fresh air into the living spaces. I can't, unfortunately, I can't diagnose a problem without seeing it, and based on explanation.
When you say old windows, what sort of age range do you mean? Like
so pre-2002s, when building regs came in on Windows. So before 2002, it could be anything from hollow plastic to quite well insulated. It's impossible to tell. Whereas after 2002, there's specific U values the frame and the window unit, the glazing unit, have to meet. So modern double glazing units have a much higher performance than the modern actual. So the glass panes have a much higher performance than those produced back in the 80s and 90s, that the argon filled and all that. It does make a difference to how the windows perform and what the central glazing value, G value, is to that.
Okay. Another very topical question. Is there a way to combine ventilation for COVID safety and draft proofing?
Yeah, and can I spring in there as well, Greg, because you were just talking about the improving the air quality, reducing humidity through having a constantly running fan. I know that there are some single room heat recovery ventilators as well, but I don't know if that's something you'd advocate.
So single room heat recovery, or any heat recovery, is only really valuable where a property's air tightness is below 0.3, 0.4, something like that. So it's only really in really efficient, really airtight properties that heat recovery becomes a sensible option. It can be a bit of so that the big thing with the heat recovery fans, which are out in the market, and single unit ones are there, they tend to be louder than just straight extract fans with demand response. So people can switch them off. So people can buy them with the best intentions and then choose to switch them off. But before going down that route, it's advisable. And air tightness testing isn't that expensive either. So you're looking at £200 to £300, I think, for air tightness testing, and that can help you diagnose where as well your heat is your heat is escaping from.
Okay. So maybe linked to that, then, is there a way to combine ventilation for COVID safety and draft proofing?
Yes, having that continuous extract ventilation would make sure you've got an air change rate that's I think the target is something like 3.5 an hour from an energy efficiency perspective. Now, I can't really talk on the COVID safety and what the correct air change rates are, but yeah, it would help. It would definitely help.
Fair enough. And from Jane Roberts, are internal thermal wall coverings helpful, presumably in external walls only, and are they a viable option for a listed building with fancy protected cornices and skirting?
There are some solutions out there. All listed buildings will have to go through listed building consent to do anything like that, in my understanding.
Is that grade 2 listed or grade 1?
Grade 2.
One of them's inside, isn't it? One of them's anything outside.
Yeah.
I think.
And
yeah.
Can we just clarify? What our questioner, was it Jane, means by these coverings? I think they're the rather thin, flexible things that can be stuck to the wall, but actually are designed to prevent condensation within the room, but not necessarily do. Is that what you meant? Sorry to jump in, Gordon.
Yeah. That is what I meant. Yes, and some of them are 2 or 3 millimeters thick, and some of them are a centimeter thick. And obviously, the thicker they are, presumably the higher the lower the U value. But I because we can't have external wall insulation, I was just wondering about internal wall insulation. And if it's worth it, but also then how you get across the cosmetic issue, because when it hits the cornice and the skirting board, there's going to be an overhang.
Yeah, so listed buildings are a real challenge, and internal features. There are a couple of ways you can go about it, and one is essentially you can choose to bury the wall that's there and recreate it so as long as you preserve the features, generally as long as what you do can be undone, generally conservation planners are fine with it. So it means sort of building a fake wall in front of your wall and then recreating your wall on that fake wall. That can lead to quite high space loss. There are very high performing products out there, such as aerogel and vacuum sealed units, which give you very high U values for a very thin layer. The thin layer stuff, where it's less than a centimeter, you're really, even the phenolic foam that I spoke about, you're looking at two odd centimeters to sort of really achieve the U value. So anything sort of £300 or anything that's sort of like 50, 100 quid a roll, and it's sort of claiming to prevent all problems, I'd be very suspicious of, personally.
Equally, the paints that suggest there's some U value. I don't think there's anything valid there, is there? Yeah,
there's no certification on any of these things that would allow me to install it as a retrofit coordinator and claim it as compliant.
And Greg, would you also be concerned if some of these are non-vapor permeable, that they could actually be damaging as well?
Yeah, that's the other factor to really consider in thank you, Jackie. To consider in listed and solid wall properties is the properties are designed to be vapor permeable, so we should really be the best practice now is to specify vapor permeable insulation, which unfortunately, as we mentioned in the presentation, I gave wood fibre as is one example of a vapor permeable insulation, and you could see how much worse that performs than the sort of manufactured ones. The really, so aerogel is a high performing vapor permeable insulation, but you are looking at something like £200 per square metre, so it is painfully expensive.
Okay,
Thank
it is.
Yeah, sorry, it's not a more positive answer. Anything you add, any insulation you add will make a difference, but there are considerable risks.
There is a member of HGN, Jane, which I could give you the contact details of, who's gone through this in Hay with a listed building and internal wall insulation, and maybe he could share his experiences with you if that's useful.
Okay, thank you. Yes, that would be helpful.
Yes, and please share with me as well, Gordon. That would be terrific. But what I'm picking up is that it might be quite interesting, actually, for us to be putting on an event that's specifically about buildings in conservation areas or listed buildings, because they do need to be treated quite sensitively, I think, for a whole range of reasons. Right, back to Gordon. Sorry, I keep interrupting.
It's okay. Vicky, this question: we live in a solid wall old house. There's an open stairs right up to the converted attic. How can we stop the heat going up? Sounds like it's the pressure building pushing heating out out syndrome. So it sounds like it's going up the heat stack, I suppose.
Yeah, so there's stack, thermal stack or ventilation stack ventilation, passive stack ventilation. That's the word. So one of the big issues, I mean, just to come on to sort of energy performance, is a lot of loft conversions have been done very dodgily over the years, and building regs haven't really. It's only recently building regs have started to recognise insulation in these sorts of elements. Best bet is probably to find out what's behind the plasterboard. If there's nothing behind the plasterboard, it's a case of redoing it, essentially. If you are doing something like that, it's really worth so talking about all these things you can do from an energy performance certificate, and if you're reselling your home, it's important to evidence all these things, because an EPC assessor can't come round and take things off and look behind things. So if you are having additional insulation put in on your internal walls, make sure you get photos of it being done. If you're having insulation put in your flat roof, get photos of it being done, so that if you ever have an energy performance certificate done, is get someone round to look at it. With lofts, it's even more serious, because EPC assessors can't take the photos as evidence. They have to have original designs for that. So it would be my recommendation would be it would be sort of look at, if you are really serious about it, look at getting the plasterboard out, installing between the joists, between the rafters on the roof, and then installing a layer of insulated plasterboard as well. Having spoken about vapor permeable in solid walled buildings, where you're treating a roof like that, you don't have to be so careful, because that's not the vapor permeable area. We're talking about the walls and the ability to sort of allow moisture in and out that way, less so with the roof and the ceiling. It's vapor, not necessarily air. So yeah, I'd look at that. The other is, I'm guessing it's a bedroom, so the other option is whether you could put on some sort of hatch or something at the top of the stairs that would at least trap the heat in the rest of the building.
I mean, whilst we're talking about loft conversions, dormer windows come up as an awful problem for heat leak, don't they, in the past? I even see conversions going on right now repeating the same problem, because dormer windows are quite often just wooden sides with some sort of covering on afterwards.
If they're doing them to building regs, they should be putting insulation into whatever building regs are. They have been, and those, and as we said, bay windows. You see in quite a few older places, bay windows are just 2 layers of wood with some windows in, or a layer of external wood and then some plasterboard or something like that.
Okay. Nick's come back again with another question. I have a solid stone wall, pebble dashed, would like to fit external insulation without compromising roof overhang, so needs slim panels. Is there anything cost effective, bearing in mind wall is a tad irregular?
With irregular walls, you'd probably be looking at stripping off the current pebble dash and then reapplying a coat. Again, it would be a case of discussing with a professional installer rather than myself as a coordinator. I don't have the ability to give that depth of technical advice on those, but yeah, anything you can add will make a difference. But the other thing is that ability to not come with the overhang. So yeah, any additional insulation is great. So yeah, that phenolic foam will perform. So 25 mil, so 2.5 an inch of phenolic foam will perform as well as 50 mil of loft insulation. So if we talk about 100 mil of loft insulation that we see in most buildings, you're only looking at a quarter of that to get the same level of performance from it.
Okay. Nick's getting his money's worth this evening. He's got another question there. So a bit worried about what Greg is saying re EPCs. Did he imply that the insulation that can't be proven in some way won't be taken into account in the EPC, or did I misunderstand?
No, that is what I'm saying, is that the energy assessor, so the energy performance certificate, and the person doing the EPC has had, and no offense to anyone who does EPCs, I do them myself. It's a 3-day training course, and there's no prerequisite to know what you're doing, and it's about. So the EPC assessor is not allowed to remove things, look behind things. So it's about what they can observe physically on the day without taking anything off the walls, unscrewing anything, looking behind anything. So yeah, it will default to when your building was built. So if building regs, it will default to what building regs or what typical performance was there when the building was built. If you can't show them photos of the insulation as it was going in, the other option you might have is that you could remove if you've put internal wall insulation in and you've got an electrical socket, you could take that off the wall so they can get a photo, but they won't be allowed to do that.
It's a bit not my field. So in other words, document and photograph anything you do, and then try and convince the EPC assessor to take notice of that. Yeah. Okay. And then finally, as we're coming towards the end, Vicky is asking, how can we get someone to do an energy assessment? Well, there's several answers to that, but one is that we will be publishing more information on this in the future on HGN's website. As we have a larger list, but I'm sure Greg can say something about it in the short term.
Yeah, so again, through us, we do have some paid for services. So we do energy performance certificates from £75. So we're not the cheapest, but we do more accurate, potentially more diligent ones. I've seen some terrible ones out there. We then do a level called EPC Plus, which is £150, which the assessor will walk around with you and give you sort of verbal recommendations, and then confirm those and write to you. We then have a level called bespoke assessments, but that is more focused on larger properties, and we're looking at 350 plus, depending on how many bedrooms and things. So those are the services we can offer. Obviously, I would say get an assessment done. But it is, if you're going to spend a lot of money doing this, making the retrofit journey, it's try and get the best advice you can beforehand.
Maybe I just pass that back
thank
to
you.
Jackie to comment on that as well.
Thanks ever so much. Yes, having had a couple of professional assessments done on properties in the past, including the one I'm sitting in, I think it really is well worth it. If you think you're going to spend some money, then it's really worth getting that overview. And there's one level of report, isn't there, Greg, which essentially becomes a whole house plan, which describes the current state of things, but also a sequence of actions that you can take over time. And if you think you're going to, if you're up for doing something big, I think that's well worth having, because it also talks about sequencing, doesn't it? If you're not going to tackle everything at once.
Yeah, so you could choose to go beyond, and it's not something we offer, though we've got, I am a retrofit coordinator. There are, you could choose to, if you're doing a big whole house retrofit or a big project, or you have aims of doing it over the next 30 years, is get a full-on retrofit assessment, retrofit coordinator in. You are looking at, in the realms of sort of the higher end, closer to £1,000 to get that done, probably. But if you're looking to spend that money, it is worth having that proper look and advice. And so it would be a retrofit assessor coming in. They'll do an EPC, but they'll also do condition reports and occupancy reports on your property. They'll then take that back to the retrofit coordinator, who will look at basically everything you could do, model it all through the SAP software that's used by new build assessors or Passive House if they're that way inclined, and be able to give you a breakdown of the cost savings every single measure could give you, and give you packages as well that would be suitable for your house. And eventually that would then result in what's called a medium-term plan, lodged through Trustmark, so you can access that going forward, or anyone who you sell the property to, if you do end up selling it. And that gives sort of a step-by-step approach, as well as focusing on sort of designing out the mistakes we've made in the past in retrofitting.
Yeah, thanks very much for that, Greg. And then, and what's more, here at Building Sense, we're here to help, because we're actually going to be having a lot more events. I hope some face-to-face events, also some expert clinics where you can actually get some time with somebody like Greg to talk about your particular concerns and help you along the journey, whatever the journey is right for you and your home or business, property or community building, or whatever it is. But you know, we're primarily focusing on homes just now, so we will be telling you more about that pretty soon. We're also planning to be working with local builders, because we know that we've got some terrific builders in Herefordshire, but not all of them are really familiar with some of the techniques to do with insulation and so on. So have I frozen?
No.
No, I haven't. I thought everyone else did to first. So if you've got a local builder that is your preferred one, when the time comes, do please tell them about what we've got to offer. We might invite you to send in some names and addresses to us, but not quite yet. So I'm going to ask Gordon to talk about our next event. Gordon, that's going to be next week, isn't it? Where we're taking a different approach. It is.
Yes, we're going to try and go to the other extreme, which is low-cost things that you can do fairly quickly to your house, mainly to try and reduce the awful costs that we are incurring with the increase in energy. And there we'll have a sort of partner to Greg in some ways, because it's Marsh's Energy Agency, who used to support us in Herefordshire. a chap called Phil Newcomb, and he's been very much involved with doing lots of work around the county, the small things that can be done to improve a house. And so we'll be giving a lot of information out about those, with training videos and other things like that associated with it. So that's the first one, and then the following event will be looking at the final part of Greg's chart this evening, which I may use, Greg, if I may. So after you've done the fabric and everything else, then you can consider renewables. But at the moment, it makes so much sense to think about generating energy if you have a roof. If you don't have a roof, then okay. But almost anybody with a roof can have renewables, and they'll reduce the carbon footprint as well. So, and of the cost balance of it is very different. So we'll do that as a second talk.
That's coming in a couple of weeks.
Yep. And maybe to end on this one question that I can see there from Vicky. Do you see that, Greg? EPC. Yes. Oh, Vicky, you've replied to her. Vicky.
Yeah. So it's a question about costs on EPCs and things that make them go down. So
oil. Vicky said replaced oil central heating with a biomass pellet boiler, and our EPC got worse. Do you know why? And I thought,
same here. Same. That happened here as well. It was actually.
We are still working off 2017 prices for fuel and 2017 carbon factors on EPCs. The problem is the minute you change them, you basically invalidate every EPC that's been done up till now, which are meant to have a 10-year lifespan. No one really thought of. Other things that will make your EPC get worse is putting in an air source heat pump or a ground source heat pump, and they're really having to look at that now with the government's drive towards these things as their chosen option. If we put in modern, more recent cost changes, you'd probably get a different answer. Because EPCs are assessing EPCs. The headline rating on EPCs is assessing the cost to run your house, not necessarily the carbon intensity of your house.
Yeah. Thanks for clarifying that. Bizarre, isn't it? But anyway, times change, and time's running out.
And time is up.
And time is up. I just want to say, Greg's mentioned the services they do, but they've also got a helpline number that he mentioned earlier. So you've got people there, haven't you, who will field calls? So anyone can call. It's there for Herefordshire. So there we are.
And we should emphasise that if you know anyone living near you in your street, or your neighbour or a friend who is in a difficult situation at the moment, then that's exactly what Keep Herefordshire Warm is all about, to support that group, and Severn Wye are doing an excellent job in supporting that. So, but it needs a trusted link, and if you could be that trusted link to someone that you know, then please do that. But
grand. Good. So we'll say huge thanks to Greg. We can't really applaud like this terribly much, but thank you very, very much. Thanks to everyone who's taken part this evening. Guess what? We'll be in touch with you again, and look forward to seeing you and seeing you in the future. And there's lots of applause for you, and thumbs us up, Greg. So many thanks.